This video, I'm going to explain the program number 12, that is write an ALP 8051 ALP to find largest element in a given array which starts from 20H of internal RAM, and you have to store that answer largest number in the memory location 40H. First we'll do largest number. After that we'll convert the same program into smallest number also. So it is a 8051 program. So we are using Keel software. You refer my video how to install Keel 8051 and all, there it is there in the YouTube channel. You subscribe my channel and you see channel list playlist, and you see a microcontroller lab. You'll see how to create a project and all. So I am going to explain the program now. So this is the program. First line is a command. Write in a assembly language program to find the largest number and smallest number, which is starting at 20H, and store the biggest number, largest number in the internal memory location 20. First line is this org. It is origin of your program. It is given as 000. So your program will start at 000. Next, move or not with 20H. Hash 20H. Hash is immediate data. So we are loading 20H in the register R0. So it is immediate addressing mode. And move R1 with 5. So this is an array which is having 5 datas. If you are using 10 datas in an array, you can give 0AH, or you can give without H hexadecimal, you can give directly 10. Okay, if you give H, it will consider as hexadecimal data. If you don't specify, it will consider as decimal data. While saving in the register, it will convert decimal into hexadecimal and it will store. So if you want to have 10 datas in an array, give 10 hash 10 only, or 0AH, or you can also write 0x 0A. Next, move B00. So initially we are assuming that 00 is the largest number and it is stored in the register B. Okay, we have accumulator A register, one more register B. You see the programming model for 8051. So we are assuming 00 is the largest and it is in B. So move B is equal to hash 00 means load B with the immediate value of 00. Next, we have to compare the first data which is present in 20H with the 00. So move A at R0. So move accumulator the content of address present in R0. In the R0 we have 20H. So content of the 20H will come to the accumulator A. After that, next instruction is CJNE. C stands for compare. Compare what? Compare A and B content. Accumulator content and B register contents are compared. And JNE stands for jump if not equal. Jump if not equal. To where? To the label next. If they are not equal, you have to jump to the label next. So once it doing comparison, A and B, actually subtraction only takes place. Both A and B contents are not affected. So based on subtraction, the carry flag is going to set or not. Suppose A minus B, compare A comma B means A minus B will be performed if A is greater. If A is greater, carry flag will be cleared. If B is greater, then carry flag is going to set. That means B is greater. So our aim is to find the largest number. If B is, we assume that B is 00. If B is initially, we assume that B 00 is the largest number. So first time it will compare first data with 0. So definitely A is greater. So that time, okay, that time I will explain with the help of the demo there. So every time when you do the comparison, whenever new biggest number comes, we have to load that value to the B register also. See, move A comma B means from the accumulator, the new largest number is you have to move into the B, and same answer you have to move it to the internal location 40H. because they are given in the problem store it in the internal memory location 40h also. So I added one more extra instruction. We can check the answer in B register also as well as in 40h location. So move B comma A means content of A is transferred to the B. Initially B is 0, 0, no, that is the largest number. Now A is largest. So you have to transfer that A content to the B. Also transfer that A content to the 40h. Next, increment or not, because next we have to compare next data and DJNZ. DJNZ means D stands for decrement. Decrement what? Decrement register R1. After decrement R1, you have to check whether R1 becomes 0 or not. If not 0, NZ means not 0. If not 0, jump. J stands for jump. Jump not 0. Which is not 0? R1 value. If R1 value is not 0, then you have to jump to the label back. So back is a label here. So it will go back here and again it will load move A comma R naught. We already incremented R naught here. So it is pointing to 21. Now actually initially R naught was 20. After increment R naught, INC means increment R naught content. So it is incremented to 21. Now content of 21H will be moved to the accumulator and now it will compare new value of accumulator with new value of B. New value of B is actually we stored previous biggest number into the B. So it is comparing that. Again, we have to complete. Again, once again, if JC, if there is a carry, you have to go to the loop. Okay, if there is a carry, you have to jump to the loop. Else, you have to transfer that new value to the B register as well as to the 40s location. So this will repeat 5 times. At the end of the program, okay, the largest number will be in the B register, and you can also check the answer in the internal RAM, that is 48. So I'm going to copy this program. Okay, this program is large number. So any old program is running, you can remove that. You can stop debug and remove the old files, and you have to add existing file or add new item, and you have to type the program. So I already have the program. Okay, so I'm add existing file. I am doing this. You have to type new. You have to type new item to the file project, and you have to select .asm and give the name as large number, and you have to type the program and save it as .asm file. In new version, it will save it as .5a1. So you can see .efi1, it will be saved. So now I'm building the build. This is a build. Okay. Second option, or you can also do project build target F7. So it will show build output. You can see the output. It is showing 0 errors and 0 warnings. So no errors. So now we can start debug. This is a red color button. This is a debug button. Start debug. You can also go here. Debug. Start. It is evaluation version. Size code size limit is 2K. Okay. Here now move R0 with 20H. Okay. So you can see the register tab is there. Is a project window. This is a register. This is project. This is register. You can see all the registers R0, R1, R2, R3. All are 8-bit registers. Accumulator A, another register B. Both are 8-bit. Stock pointer, deep data pointer is 16-bit. Program counter is also 16-bit. It is program status word where you can see the carry flag, also auxiliary carry, overflow flag, parity flag, and all. Now we'll execute step by step. Move R0 with immediate value of 20. It is loaded. So whenever you execute single step, which are the registers modified, they will be highlighted with blue color. Move R1 with 5. Move A at R0. So now you have to open view memory window 1. Okay, you have to select this window 1. Click this. I already opened here already 3 windows. So here you have to change the address to, you have to type capital T colon 0x20. In 0x20, I have to enter 5 data. So double click on that and you can give any 5 data. So randomly I will give 56, then I'll give 34, then I'll give A5, then 98. 5 data you have to give any random data, you whatever you think you can type there. Double click, or you can also do right click in the first data and modify the memory location at d colon 0x20, and here using comma you can directly enter all the data like 556h comma 34h comma, like that you can give whenever you have hexadecimal, that is starting from data starting from A B C D E, you have to type 0A5. Okay, 0A5h. Okay, then 98h, and for example now I am giving 35h. 25 will be erased now. Here you can give all the data using commas, or you can double click the position and you can give the data. So let us to execute. So move A comma tar not. So at tar not we have 20, r naught is 20, so content of 20h is 56, so that will be moved to accumulator. See 56 came here, it will compare. B is 0 0, it will compare, and you also observe carry flag also. A minus B, A is 56, B is 0 0. A is 56, B is 0 0. So carry flag is not set. Okay, if there is a carry, JC means if there is a carry, jump on carry flag bit, jump if carry flag is set. You have to jump to the loop. Else, what you have to do? You have to move A value to the B. So your carry flag is not set to 0. So we are moving A to B register. See, it came. Now the new biggest number is 56. Also you have to store it in 48. Also you have to store. You can see here in the 0x20, 20, 30, 40, 50, everything is available. So you have to adjust this. I adjusted this width of this one so that 16 data are coming here. So this data is 20h, 50h, 40h, everything is coming. So you can drag this like this. So you have to adjust this one such that in each you can have 20, 30 like that. So you can stop here. So this is 20h, 21, 22, 23, 24. And here this is 30, 31, 32h. This is 40h location. New data 56 is coming. New biggest number 56 is coming here. Now increment R naught becomes 21. Okay. Now decrement R1. DJNZ means decrement R1. R1 is 5. 5 becomes 4 now. 5 becomes 4 now. If it is not equal to 0, okay, if it is not equal to 0, jump to the label back. Back is all are this green colors are label. After the label, we should use colon. So back is a label. It is jump to the cursor. You can see here. It came to here. Move A comma turn. So we are after increment now it is 21. 21 content is 34h. Observe in the memory window 1. 34h will come to the accumulator. Register accumulator. Now compare 34 with 56. Compare 34, 56. So 34 minus 56, definitely 34 is less. So carry flag will be 1 now. 34 minus 56. If there is a carry, then no need to exchange. Then no need to exchange. You have to skip these two lines. So jump to the label. If carry flag is set, jump to the label loop 1. So you can give any label. You can type skip, or you can type L2, or you can type L3, or you can type any label you want, you can type. And same label you have to use here. So label is loop 1 or L1 or any suitable name you can give. So next, without exchanging A value, B value, B is already greater, no? So don't change it. increment or not, you have to come to this position. Now this pointer will come to here and again increment or not. Okay, then djnz r1 becomes 4, from 4 it becomes 3. It is not equal to 0, go back to the line number 6 once again, take increment rh. So already I have over, no, now it will take a new data, that is a5 value will be taken and it will compare. Now a5 minus b value is 56. Now carry flag is not going to set, so that means a is greater. Again you have to transfer that the new value of greater into the b register, also into the memory location, and you have to continue this. So this will continue 5 times. At the end of 5 times, you can see after a5 we have all less values only. So at the end of the line, the last line is short jump to dollar, means it is same as give some label here, L3, short jump to L3, L3 short jump L3. So giving the jump location to the same line, instead of that we can write short jump to dollar, means for infinitely it will be stay in this line only. Another way for writing this one is you write some label here, L1 or L2, SJMP L2, same label, whatever label you give here, same label you have to mention with the place of dollar sign. Otherwise, don't write any label here, just write SJMP dollar, it will stay here only. See, I'm clicking next line, it will be here only. So how to check, verify the answer? You verify the answer in B register, it is showing A5. Also you verify, because in the program it's given, store it in the internal memory location 40H. We already stored the using this instruction, move a comma, move 40 comma H. This is the direct addressing mode. Accumulator content is directly moved to 40H internal location. Okay, 40H internal location. So it is already there in the 40H. So this is the output. So to convert same program for smallest number, same program, you can convert, find the smallest number. What you have to do is change in the line number 8, change JC to JNC. So that means whenever A is smaller than that, then you have to move that new value smaller to this. So in that program, initially you have to load B with FF, 0FF. So you have to assume that FF is the smallest number. In the largest number, we are assuming 00 is the biggest number. And in the smallest number, initially you have to assume 0FF is the smallest number. So I'll stop debug. When if you want to modify the data, you have to modify. Now I'm typing 0x, you have to write F0 starting. 0FFX is the smallest number. Okay, you have to assume this is the smallest number. After that, here you have to give JNC. Okay, here you have to change. If A is, instead of A is greater, you have to type here A is smaller. Okay, then the same program will be converted into smallest number. Now you can see I changed what? Move B with instead of 00FF, and instead of JC I changed it to JNC. Now the same program will work for the smallest number. So build target once again and give random data, 5 random data. Right click on the first data here, or you can double click and change the value there only. 5 times you have to do, otherwise you can directly give any 5 data here. So I'm giving 98H, then 56H, I'm giving 05H, comma 0A5, comma. If you give wrong number, okay, if you miss a H and all, it will not take the any value. So you have to double click and you can type that. So I entered 5 data. So you can see 96, 56, 05, A5, 34. 05 is the smallest number that should come in the B register as well as in lamb location 40h. So start debug. Okay, I can observe initially ff is the smallest number. It will compare a with ff. A value is now 98. 98 minus ff. 98 minus ff. So definitely carry will be there. If there is no carry, then you have to skip this. Otherwise, now carry will come. Carry will come. Whenever carry comes, you have to exchange a value to instead of ff's smallest. Now a is smallest. That is 98 is smallest. So B register 98 will come, and here also in 40h also 98 will come. See here 98 came, and in the B register also 98 came. Similarly, increment R0, decrement R1. If it is not equal to 0, jump to back label. Again, take the new value of R0 into A, that is 56. Compare with 98. Okay. Again, 56 smaller than 98. Again, you have to replace that 56 into the B register as well as to the 40h location. Next, take 5 into the accumulator. Okay. 5 into the accumulator. Compare with 56. Again, carry flag will be set. So transfer that A to B register as well as to the 40h location. Next time we are comparing A5 with 05. That time no carry. If there is no carry, you have to skip and no need to transfer into the B register. So again increment or not. So next two times no exchange. So at the end of the program, you can see in the 40h location, in the 40h location 05 is there, and as well as in the B register also smallest number 05 will be there. Okay. So remember in the largest number, initially assume 00 as the largest number, and you have to use JC. For a smallest number, FF you have to assume as a smallest number, and you have to use JNC in this program. So same program will work for smallest as well as biggest. Two lines you have to change. Okay, thank you.